All right, we are going to do video number 2 here. And we're going to continue with angles and arcs, and we're going to start with the arc addition postulate. All right, so for your arc addition postulate here, we're going to talk about arc AB, and we're going to use this circle that's right above it. So I'm going to highlight here arc AB. Arc AB is this section right there, plus arc AC. All right, so if I take those two parts right there and I add them together, I will get arc BAC. All right, so this is arc addition postulate. You take your two smaller arcs and you add them together and figure out what other larger arc you get. So let's take arc BDC. So BDC, and I'm going to highlight this in a different color. This BDC plus AC. And what larger arc do we get? We only need 3 letters, and you always want the 3 letters that the first one needs to know where you're starting at. So we're going to start with B, and we're going to end over here at A. Now the middle letter, I need to choose either D or C. It does not matter which 2 I choose. Both of them will be correct. And I'm just going to pick D just because it's right there. And or you could have done B, C, A. Either one of those are correct because they cover the same amount of space through there. But it does need to have the A and the B on their ends. It could have A first and B in the last, but it still needs to have A and B at the start and end. All right. Now you have this next section here is going to deal with congruent arcs. Okay, and if you know what congruent means, it means they're the same, or congruent circles that have the same measure. Okay, they're in the same or congruent circles that have the same measure. All right, moving on here, and we are going to start with the next part here at the top, and we are going to have adjacent arcs. All right, adjacent arcs are arcs in a circle that have exactly one common point. So adjacent means they are beside of each other. So HJ is adjacent to, so let's highlight where HJ is. Here's HJ. So what arcs are beside of HJ? If I'm going to go to immediately beside of it, I would say JK is adjacent. I could also go on the other side of it and say HX is adjacent to HJ. So I can go to either side of that, and those are going to be adjacent. Notice they each have something in common. This one has J in common, and then these two have H in common, and they share exactly one common point. All right, example, AC and EB are diameters of circle R. I don't know what happened to the R. Let's put it in there. Identify each arc as major, minor, or semicircle and find the measure. Okay. EA. EA is right here. And EA is a minor arc. So now this is something that we need to realize right here. This angle right here is 50 degrees. With central angles, so remember a central angle is coming from the center, and that's what this is coming from, the center. If the angle is 50, that means the arc will also be the same measure. Central angles and their arcs have the same measure. So if angle ERA is 50, that means the arc EA will be 50 degrees as well. CB. Okay, CB is over here on this side. CB is less than 180, greater than 180, or equal to 180. And if you notice that it's going to be less than 180, so it is a minor arc. And if you look at these two angles, where the 50 is and this one, these are what you call vertical angles. Vertical angles are congruent to each other, so that means CB will be 50 as well. So I can put that in there, 50 degrees. Now let's do DEB. DEB. All right. We know that EB, it said, was a diameter. So if E to B is a diameter, that means this part of the circle has to be 180 degrees because it's a semicircle. And with that semicircle, I need to add this 30 degrees. So 180 plus 30 degrees is going to be 210 degrees. That 210 degrees is greater than 180, so this is a major arc. Now let's do the last one here, CDA. CDA. And if you remember, up at the very top right here, it said AC was a diameter. So here is a diameter. So I want CDA. And that is going to equal 180 degrees because that is going to deal with my semicircle. And that's what I have right here is a semicircle. All right. Let's move on to the next section here. Finding arc length. Okay. Arc length is a distance between the endpoints of the arc. This is where you need to think about your circumference formula. When you're finding arc length, you're only finding the distance from two definite points. So you're finding part of the circumference, not the entire thing, but just part of it. So finding part of the circumference formula is what you're going to have here. Formula for the arc length is L for length equals central angle divided by 360 degrees. And you're dividing by 360 degrees because that is how many degrees is in a circle, times 2 pi r. And if you remember, 2 pi r is your circumference formula. So we're using all of that right there. So L means arc length. X is going to be your central angle. So a lot of times you're just going to see X over 360 times 2 pi r. So that might be something you may see as well. So X means central angle. Pi means 3.14. And R means radius. Okay? So you have your arc length, your central angle, pi, and radius is what we need for this formula here. Now let's do some problems here that's involving the arc length. NL is your, NL is your diameter of circle D found to round to the hundredths is what we're going to do. So hundredths means 2 decimal places. LM, arc LM, is the radius. If the radius is 5 inches, we're going to figure out what the arc of LM is. So LM is right here. So LM. And I don't know what this angle is, so I've got to figure out what that one is. And if I know that LM is a diameter, I know this is 80, so I can just do 180 minus 80, which would give me 100 degrees. So this right here would be 100 degrees. So I would need to do 100 divided by 360 times 2 pi, and if my radius is 5, so times 5. Now I'm going to put all of that into my calculator, and instead of pi, I'm going to do 3.14. And when I do that into my calculator, I got 8.72. So what I would hit would be 100 divided by 360 times 2 times 3.14 times 5. And I got 8.72, and I need to put inches on that. MN, if the diameter is 3 yards. Okay, so MN is located, right here. And I do know this angle right here, so it's going to be 80 over 360 times 2 times pi times 3. And so in my calculator or on my phone, I would do 80 divide 360 times 2 times 3.14 times 3, which would be 2.09 yards. And then my last one here. And this one, I'm going to have JKM. JKM is dealing with this part of the circle. And my diameter is going to be, and I don't know if you guys realize this, I messed up on this one. This says diameter is 3 yards, and this formula is dealing with radius. So instead of a 3 right there, I should have used, I can't erase that, I should have used a 1.5. That is my fault, because I'm going to take half of 3, so I'm going to do 3 divided by 2, which is 1.5, and put that right there, because you need your radius in this formula. And I'll be honest, it does still come out to be 2.09, because I'm looking at my other sheet of paper here where I have worked it out, and I wasn't paying attention. I'm sorry about that if I confused you. But I do have diameter here. So when I'm doing 2 pi, I'm going to use 10 feet right there, because I need my radius. I'm sorry. So JKM, JK and M. I know all of those together, so I'm going to do 50 plus 60 plus 100. And if I add all of that together, that gives me 210. So I'm going to do 210 divided by 360 times 2 pi times 10 equals 36.63 feet. So my calculator, I will do 210 divided by 360 times 2 times 3.14 times 10. Be careful and make sure you're seeing if it's telling you radius or diameter. Don't do what I did like on this second one right here. Pay attention to your words. And you are going to do numbers 7 through 16.